have a direct effect on cancer cells. Did they, go down? Were they reduced? That's the dependent variable, the outcome. I talked about nuisance variables. Some people call them extraneous variable, confounding variable, influences the dependent variable but cannot be separated or is not attached to the independent variable. I'll give you an example of this. Let's say that I'm a licensed therapist, a mental health therapist. So I go into the school, they call me up and they say, little Johnny is throwing chairs, cussing teachers out. We had to send him home. And this is the 10th time we've had to send him home this month. Well, I go in, I start working with little Johnny. I provide to him cognitive behavioral play therapy because he's a little guy. That's my independent variable. Now my dependent variable is going to be the reduction in anger. So his anger outbursts, he's not throwing chairs anymore, he's not cussing the teacher out, and he's not getting sent home as often as he used to. So there's been a significant reduction in his anger. So I've got my independent, my dependent variable right there. That's why so many people love cognitive behavioral counseling, is because it's set up like research. We have a research type of outcomes called evidence-based counseling. So we're trying to control for all these confounding variables. Let's say that a new youth minister moves into town about the same time I start working with little Johnny. I don't know about this, but he's been going to church every Wednesday and working with this new youth minister. And then when I finish up my study, I notice a significant reduction in anger. But I don't know about this youth minister. And then little Johnny tells me about him the last week. I'm going, well, maybe it's not me. It may be the new youth minister that had this direct effect on the reduction of anger. That would be a good example of a confounding variable. Subject samples. Is the sample large enough? Well, if you are a researcher, you can do what's called an a priori study or a statistical analysis, a priori analysis, and you can determine how large your sample size is to determine if you've got enough power. Power is basically 1 minus beta, and we're going to get into all the alpha beta stuff. So that's power. And you want your power to be at least 95%. So there's statistical procedures in order to tell you, is my sample large enough to get the results that I desire? How was the sample selected? That's a big question. How did you get your sample? Was it a convenient sample? Well, there's nothing wrong with that as long as you let people know that this was a convenient sample. Is the sample representative of the population? Now that's real important. You don't want to say, well, I'm going to change the behavior of 6th grade boys, self-esteem or whatever, and then you got mostly girls in your study. And that's happened a lot because a lot of times they can't get enough participants, so they'll get participants however they can, and the sample may not be a representative sample of the actual population that they hypothesized in the beginning. And then we've got ambiguous averages. Ambiguous is just a fancy word for not clearly defined, so it's not crystal clear, it's not concrete, it's just kind of wishy-washy, it's ambiguous. What particular message of an average was used and why? So if I say that the average income for Okmulgee is about $60,000 per household, that would be pretty accurate, I think. I'm not saying it's perfect, but I'm just throwing out a number. Now, Donald Trump moves to town and sets up shop, buys a house. He's worth like a gazillion dollars or something like that. I don't even know. So what he's going to do is he's going to skew the average, and he's going to skew it very significantly in a positive direction because he makes a whole lot more than $60,000 a year. He probably makes $60,000 a second. I don't even have a concept of what he makes. I don't even want to know. It would probably be depressing. So what I don't want to do now, if I have him living in town, I don't want to report the average income because it's not going to be a clear representation of what most people make in this particular town. It would be way out of the ordinary. So I'd have to use other measures like the median, which would be the actual center of how much money everybody makes. So that would be a better indication of the true average than the average if you have some really, really super rich guy like Trump move to town. So that's why we have ambiguous averages. We can manipulate those, and we got to be very careful when we report averages. Changing the subject, are different values used to represent the same data? We got to be careful about that. Sometimes people do that. Detached statistics, you know, we got to be careful of using this too. 1/3 fewer calories. What? You know, 1/3 of what? So we got to be very careful when we report things that we're very clear and concise, and people can understand that, you know, these values have boundaries. That's why those boundaries in classes and things like that are so important. And then implied connections. We imply things. Studies suggest. Well, what studies? You know, I'd like to know that some people may understand what this statement means. You know, I would be very careful when they say, studies suggest, or research tells us. You know, there's nothing wrong with saying, you know, what research? You know, and you may not be able to quote a citation or APA citation or something like that and say, well, this came from such and such. But you can at least know, you know, kind of where this came from. Well, this was a study done at Yale University about 3 years ago, because I talk a lot about studies and I talk a lot about different type of research in my classroom that's been conducted, because it's very important for students to understand that research does help us understand better the world that we live in. Misleading graphs. Are the scales for the x-axis and the y-axis appropriate for the data? I don't know. I don't even understand that stuff. So, you know, when we're talking about correlations, I can give you a really quick example of a correlation and what it means and how it works. So I've got this y-axis over here, and I've got an x-axis over here. And I can say that these two scales are positively correlated. So that doesn't really mean anything unless you know what the actual correlation is. And the symbol for a correlation is going to be R. So R is equal to some number. So let's say we've got ACT scores here, and we've got GPA over here. I'm going to just assume that those two things are related to each other. They should be, because if I make a 4.0, I'm more likely to probably have a high ACT score. So let's just break it down into, you know, categories here. 4.0, 3.0, 2.0, and a 1.0. 36, 26, 16, and 6. How's that sound? I've known some people that had a 6 on their ACT. Didn't reflect their GPA. So this probably won't work. So let's say this person made a 6 on their GPA and they had a 1.0. Let's say they made a 16 and they had a 2.0. A 26, this person had a 3.0. This 36, 4.0. Now I have a perfect positive correlation, so my R value is going to be equal to 1, or 1.0 if you want. Now any deviation from this, let's say this 1-point GPA person wound up making a 10, so it might be right here. So think of this is what's called a regression line. So think of that a regression line as kind of like an average. So, you know, I got different people, you know, a 1.5 may have made a 5 or something. So that's going to vary from this regression line. So when I start seeing different data points that aren't aligned with this particular regression line, I can actually see a direction. This is still a very positive direction. However, it's not perfect. So my R value over here, without calculating anything, would probably be equal to like 0.80. And what that means is 80% of the two variables share something in common. And it's very strong at 80%. So 80% of these two variables are shared. That's what that means. And we'll get into that in more detail. But we can have negative correlations too, and that just means one variable goes up and the other one goes down. We'll have a positive negative, or a high negative correlation. But that's what this is. You know, graphs can be very misleading if you don't know what to look for. You can just say that, oh, there's a positive correlation here. Okay, how positive? You know, you could say that you've got a positive correlation of 0.40. So that would be 40% of the two variables. That's not very high at all. That's very weak. Faculty survey questions. Do you feel that statistic teachers should be paid higher salaries? The answer to that should be yes, of course we should. Do you favor increasing tuition so that colleges can pay statistics teacher higher salaries? You're probably going, oh heck no. No, keep them where they are. I don't want my tuition to go up. I don't want you to have to pay more money for me to get more money either. So I'm okay with that. So I want to make more money, of course, but I don't want it to be at the expense of making you financially uncomfortable. And here's some computers and calculators that can be used. I use SPSS when I do my statistics. You can use Excel, you can use Minitab, and there's stuff that you can actually program yourself. I had to learn how to use that when I was at the University of Arkansas. It's called SAS, but it takes almost as long to write the program as it does to write your research up. So it's pretty complex. But in this class, we're not going to use computers and things like that. Everything we're going to do hand calculations, since this is all elementary statistics. And they're going to be very small data sets. So I just want you to get a good understanding of numbers and where these numbers are coming from and how they can be applied and how you can use them when you go out and get in the field of the world of work. So I appreciate the opportunity to teach this class. Hopefully, you get a good feeling for the class. I don't want to make it really hard and difficult for you. I want to make it fun, enjoyable, and if you get a chance, just let me know if these videos are good, or if they're bad, or if there's something I can do better. Let me know. I like comments. I like you to give me some feedback. Let me know if there's something more that you need. We do have tutors here if you're not understanding some of the mathematics and things like that. However, the nice thing about these videos is that you can rewind them and watch them over and over and over. I'm not sure if you want to do that or not, but you're more than welcome to. So I'll be posting another video tomorrow morning, and that will explain the homework. All right? So have a good night, day, whenever you're watching this, and I will see you next time.